Okay, I'm going to do the very first question in the exercises to hopefully, explain, clarify, get you used to related rates. It shouldn't be too tricky, but this is entirely new for you guys. So A and B are variables. Now that's important. They're not constants. They're like an X and a Y. In the next question, I can see an area, so these things are variable and they're not always going to be labeled as X's and Y's, although often they are. I can see in this square, we've got X's, and here they're saying rectangle, X and Y. So, I mean, I could write this question with X and Y, but they've called them A and B, and it's important that you realize they're variables. They are related by the equation ab cubed equals 40. Differentiate the equation with respect to t, so that will require implicit differentiation. The good news is they're giving you the equation in question 1. Sometimes you'll have to come up with it. Now the information they're giving me for B, there's an instant when A equals 5. B is increasing at 1 unit per second. All right, so the A and B can change as long as they adhere to this relationship. They can change with respect to time. And we'd be interested in, well, when the A is 5, they haven't told me what the B is, but they've told me that the B has a rate of 1 unit per second. Then they say, what is happening to A? All right, so I've written that information down here. I've got my equation. They've told me A is 5. They told me B is increasing at 1 meter per second. And so that is the dB dt, right? You can see it's a rate. I'll just put the units in. Meters per second. Then they said, what is happening to A? What they mean by that is you need to solve for dA dt. All right, so back to part A, when we differentiate this with respect to time, and it's like I've got an xy equation. I've got some function a or x based on time and some function y based on time, and they're multiplied together. So this is a product, and you'll need the product rule to differentiate it. So the derivative of a, now don't get confused here, it's just literally the derivative of a times function b plus a derivative of b. Now this one, you've got an outside inside, so you can't just write dB dt. You need to look at the outside and say, well, I've got 3, might put it in brackets, 3b squared dB dt, and again it's implicit differentiation. So I've done a product rule, which you're familiar with u's and v's, yeah? So derivative of a, well, that was easy, just literally the derivative of a. Function b cubed, that's the v. Then you've got function a and derivative of function b with respect to time. So that's all we're doing there. We know it equals 40. I didn't finish it, did I? But in terms of derivatives, that will equal 0 because it doesn't matter that I'm differentiating with respect to x or y or t or whatever. It's a constant and its derivative will be 0, right? So I've said it, but I just want to be clear. If you ever see a y in an equation and you have to differentiate that, it's literally dy dx, right? If you're doing implicit differentiation. If you see, like here we saw an a, and we wanted to differentiate this variable with respect to time, I'm just going straight to dA dt. Hopefully I didn't make that more confusing than it needed to be. Now in this question, part B, we're trying to find the dA dt. So I like to rearrange it and get a dA dt equals. Let's do it in 2 steps. So we'll get negative 3ab squared times our dB dt, which I guess because it's question 1, they've made this pretty easy. They've made this number 1, so that will be easy to deal with. We need to divide by b cubed. So we've got dA dt equals minus 3ab squared on b cubed, and you can see the b's, there'll be some cancelling there, times dB dt. So let's tidy it up. They'll cancel out. That will go to 1. Can I erase that easily? Yeah, there we go. Nice. Right, and these two things are multiplied. So again, in this question, like in the previous video, there's actually 4 different things happening. I've got the rate of change of A, I've got A itself, I've got a B, and I've also got the rate of change of B. I'm trying to find rate of change of A, and I'll need to know these 3 values to now substitute in. Okay, you see in the book, they do make a list. Just see what page it is. And if I can get there easily, my internet's playing up a bit. I don't know, there's a green box and it's got a list of advice when doing these questions, and it's things like draw a diagram if it's applicable, and that type of thing, and differentiate, come up with an equation that relates the variables and differentiate it, and don't make things constants that aren't constants too early. So at some point I am going to have to come in and substitute in an A, a B, and a dB dt, but these things are variables, so I'm not going to from the start take this equation AB cubed equals 40. They've told me that A is 5, right? So couldn't I write this? And it's like, well, at the instant we're interested in, you can, but it's a variable. So in terms of the relationship, you can't, right? So to get the equation I need to calculate dA dt or whatever, I don't want to be changing that to a 5 because it's not always constant. Now I will need to change it to a 5 because I need to know what the B value was. I'm missing a B value. If you but that's only at that particular instant, right? So I've got an A, they've given me my dB dt, I wrote that down, but I don't know the B value. So at this particular instant when A is 5, I will put it in so that I can get the B value, which, what's that go? 40 divide 5 is 8, right? So something cubed equals 8, B's got to be 2, right? I'll put that up here in my list of things I need. But don't put in the, I mean, it's sort of obvious, isn't it? To come up with these equations, you can't be putting in the values at this particular instant. 5 times 2 cubed equals 40 too early on, and then trying to differentiate this with respect to time. That you're not going to end up with a equation. So hopefully the point I'm trying to make there is making sense. Leave the substitution till the end. It's making me think of some other things I want to explain, but I won't. So let's just finish this question off. At the instant I mean, you could even write something like this. At the instant when the a is a 5 and the b is a 2, then the derivative will have to equal minus 3 times 5 divided by 2, and they made this question easy by making the rate of change of b was just 1. And so we'll end up with 15 on 2. Actually the same answer as the last question. We were dealing in meters per second again. And if a was increasing, no, b was increasing at this point. Okay, so if b is increasing, a must be decreasing if we want to hold this multiplication constant. So you could say something like a is decreasing at, what if I write, well, I've said decreasing, I don't need the negative anymore. 7.5 meters per second. Okay, so hopefully I explained everything I wanted to and you followed all of that. And I'll leave that video there.